Hi, welcome to Lesson 17, Session 3. Today we're going to be continuing our work in dividing with decimals. Yesterday we talked about how to divide a decimal by a whole number. Today we're going to be talking about dividing by tenths and specifically dividing a decimal by a tenth. So we're going to be working on pages 357 through 362. So go ahead and open up your Ready Classroom math workbook to page 357. All right, so on page 357, we've got some pretzels, and we're going to learn a little bit about what's going on with these pretzels. So we have Grant, and Grant has 3 6/10 of a pound of pretzels. He puts the pretzels into bags that each hold 3/10 of a pound. How many bags of pretzels does Grant use to hold, or how many bags does Grant use to hold the pretzels? So we're talking about pretzels in this problem. And what we want to know is how many bags does Grant use to hold the pretzels? And the information that we're given that helps us solve this problem is that we know that Grant has 3 6/10 pounds of pretzels, and each of the bags of pretzels holds 3/10 of a pound of pretzels. So now we need to figure out how many bags do we need, because these pretzels need to go inside of a bag. So to do that, we're going to go ahead and look at the problem like this. We have 3 6/10 pounds of pretzels. This is the total amount that we have. We know that we divide them up into bags, and each bag holds 3/10 of a pound of pretzel. We need to know how many bags is that. How many bags is 3 6/10 divided into 3/10 of a pound bags? So to do this, there's a few different ways we could do it. But my favorite method, because you know how much I love to highlight, is to use these decimal grids. So these decimal grids, I'm going to use this to show, and it's going to show, I need to show what does 3 6/10 of a pound look like. So 3 would be these 3 holes plus, and then I need to have 6/10 of this here. So I'm going to show you what watch. So we've got one, so this is going to be one hole that's all the way full, another hole that's all the way full, another hole that's all the way full, and then 6/10 of this is all the way is full. So 1, 2, 3, 4, 5, 6. So that's a really rough drawing, but as you can see, we have 3 6/10 full. Now we're going to go and we're going to say, all right, we need to break this 3 6/10 into bags that are 3/10 of a pound. And we know that each one of these is a full pound. Okay, so we're going to go, all right, well, right here, this is one group of 3/10 because I have 1, 2, 3/10. Then I'm going to take the next 3/10 and draw a line. That is my second group of 3/10. Then I'm going to make a third group of 3/10. Now I have 1/10 left over. I'm going to take 2/10 from this group and then draw another line. That is 4 groups. And then 5. And then 6. And then 7. As you can see, all of these are 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So as you can see, I've taken this 3 6/10 and broken it into 12 equal groups of 3/10. So 3/6 divided by 3/10 equals 12 bags. Now, there's another way that I could have done that if I didn't want to use my decimal grids. So the first method that I used here is decimal grids. Now remember, this is the decimal grid method. I colored in all of my tenths, and then I counted up groups of 3/10, and then I counted how many groups I had. Okay, another way that I could do this is using my place value. So if I had 3 6/10 divided by 3/10, I could change both of these into whole numbers. So 3 6/10 is equal to 36/10. And then 3/10 is equal to 3/10. Now, once I have my two whole numbers, then I can say, all right, well, I know that 36/10 divided by 3/10 equals what? Now, when you divide a tenth by a tenth, it's kind of weird, but what happens is this tenth and this tenth kind of cancel each other out, because you're saying you're taking away you're dividing a tenth by a tenth, which basically means that you can kind of cancel those out. That's what that means. So now I'm looking at what is 36 divided by 3. You can only do this when you're dividing by the same place value. So now 36 divided by 3 is the same as what number times 3 equals 36? Well, if you know your multiples of 12, you know that 36 divided by 3 would be 12, because 12 times 3 equals 36. So we know that if we have 3 6/10 pounds of pretzels, we divide them into bags of 3/10 of a pound, we're going to need 12 bags of pretzels. Crazy, but let's keep going. Go ahead and go to page 358. So on page 358, we see the same decimal grid that I drew, so we don't need to do much more work there. And then down here, we also, and this is using the decimal grids, then the model it is using the relationship between multiplication and division to understand the problem. So this is kind of what I showed you. 3 6/10 divided by 3/10 equals n. N is the unknown number. That's the same as that unknown number, or n, times 3/10 equals 3 6/10. And then remember, using place value understanding, we can find the missing factor, so that we know that 3 6/10 is equal to 36/10, and 3/10 is equal to 3/10. So therefore, what number times 3/10 equals 36/10? So remember, any number times a tenth equals a tenth. So if we had 12 times 3/10, that would equal 36/10, because 12 times 3/10, well, we know 12 times 3 is 36, and then if we don't know where to put that decimal, remember 3/10 has one digit after the decimal, so our product needs to have one digit after the decimal as well. So 12 times 3/10 equals 3 6/10. Let's go ahead and move over to number 1 on page 359. So looking at the picture it, how do you decide what to shade? How do we know what we're shading in this case in blue? So we know that we needed groups of 3/10. So we shaded in groups of 3/10 until we got up to 3 6/10. Since we knew that we had a total of 3 6/10, and we knew that each group was 3/10, we went ahead and shaded in all of our groups until we got up to 3 6/10. And then we counted the number of groups that we created, and we see that we had created 12 groups. Number 2 says, why are the grids separated into groups of 3 columns? So why are each of these groups, why do they each have 3 columns? Well, Each group has 3/10 of a pound. So each column is 1/10. 1/10, 2/10, 3/10. Number 3, now we're looking at this model it, okay? How did you know that this is a division problem? If we started with 3 6/10 and then we know that we had groups of 3/10, how do we know we're dividing? Since we know the entire amount we have, and the size of each group. So in other words, we know the total. So when anytime that you know the total amount, and then you know how much you're breaking it up into, or how big each group is, or how many groups there are, we know that we're going to divide because we already have the entire amount. That is why we know we're dividing. Remember, in multiplication, we know the parts, but we don't know the whole. In division, we know the whole and we know one part, but we don't know the other part. So that's how we can find the difference between multiplication and division. Number 4, explain why 33 6/10 equals 36/10. Remember, like I've shown you in past, we have this 3. 3 wholes is how many tenths? Well, we know that 3 wholes equals 30/10. Maybe if I could spell. 3 wholes equals 30/10 because there are 10/10 in one whole. So there are 30/10 in 3 wholes. Then in this 6/10, 6/10 is equal to 6/10. When we add our 30/10 plus 6/10, it equals 36/10. The other thing we can do is look at this 36 as a whole and then use the least place value and say 36/10. Now, number 5 says both the picture it and the model it tell you that Grant uses how many bags? Remember, he uses 12 bags of pretzels. So now we need to explain how to divide tenths by tenths. So what you do is you write each decimal as a whole number of tenths. So remember, 36/10 and 3/10. Then you can divide the whole numbers. And in this case, there's no decimal to put back into the problem because we're dividing a tenth by a tenth, remember I told you that when we divide a tenth by a tenth, you're like canceling each other out. So you don't need to worry about that whole number. So now for our reflection, we use 2 different strategies. We use the relationship between multiplication and division, or we can call this the place value relationship, is one strategy. And then the other strategy is to use decimal grids. So what is the strategy you like best and why? Go ahead and fill that out. And when you're done, you can turn to page 360. All right, on page 360, we have 3 problems that we're going to work on together. I don't know, I might do all of them with you, or I may leave one for you to do. We'll decide. All right, let's look at this here. It says, how many dimes are there in a jar of dimes worth $2.70? So first of all, the word dime, that's really important because dime doesn't really give us, well, it gives us a value, but it doesn't tell us what that value is. So we have to know what a dime is. So a dime is worth how many cents? A dime is equal to 10 cents, or 1/10 really, but we're going to say 10 cents, okay? So now we need to know how many dimes are in $2.70. So we know our whole and we know our part, but now we won't need to know the other part. So we know that we have $2.70 and we're dividing it by 10 cents. What is our value? So the first thing we're going to do is we're going to change both of these. In this case, I'm going to leave it as hundredths, even though, because we're talking about money. So even though these zeros, we don't need to worry about them because they are just placeholders, I'm going to leave them there because we're talking about money. So $2.70 is the same, or 2.70 is equal to 270 hundredths. And then 10 hundredths, or 10 cents, is equal to 10 hundredths. So now when we divide 270 by 10, remember these 2 hundredths are going to cancel each other out. So 270 divided by 10. Well, how many groups of 10 can go into 270 without going over? So let's use our multiplication chart to see how many times 10 goes into how many multiples of 10 goes into 270 without going over. So we have 10. 10 times 10 is 100. 10 times 20 is 200. 10 times 30 is 300. Oh, I can hear you right now saying stop. We can stop because 300 is too high. So 10 times 20 is 200. So our first partial quotient is going to be 20. 10 times 20 equals 200. Then we're going to subtract. 270 minus 200 is 70. Now our next partial quotient is how many times does 10 go into 70 without going over? I could use my multiples of 10, 1 through 10 chart and use this bottom, but I happen to know that 10 times 1 is 10, 10 times 2 is 20, 30, 40, 50, 60, 70. So I know that 10 goes into 70 evenly 7 times. 7 times 10 is 70, and we get 0 left over. When I add together my two partial quotients, I get a total amount of 27. So how many dimes are there in a jar worth $2.70? There are 27 dimes. So for now, when we are dividing a decimal by a decimal, we're going to get a whole number. It will not always be that way. But when we are working with the numbers we're using in 5th grade, it will be a whole number. Okay. But in life, it will not always work out quite so evenly. These are definitely like numbers that are made specifically for 5th grade to work out perfectly. With that, let's go ahead and try another problem. We're going to look at what is at question number 9. It says, a fence is 52 5/10 meters in length. Posts divide the fence into sections that are each 3.5 meters in length. How many sections are in the fence? Show your work. So we're talking about a fence. We want to know how many sections are in the fence, and we know that the whole fence is 52 5/10 meters long, and we know that the sections are 3.5 meters long. We want to know how many sections there are. So what is 52 5/10 divided by 3 5/10? So we're going to go, all right, 52 5/10 is equal to how many tenths? Remember to think of this as a whole. That's right, 525 tenths. Then we're going to think of this 3 5/10 as 35 tenths. And then we're going to go ahead and divide the whole numbers, remembering that the tenths they cancel each other out because a tenth divided by a tenth, it equals nothing. So like it equals a whole. So in other words, not like they cross cancel, and so then we've got 525 divided by 35. So let's see how this works. So how many multiples of 10 does 35 go into 525? Well, I know that if we were using our multiples of 10 chart, 35 times 10 is 350. 35 times 20 is 700. So it's only going to go in one multiple of 10 because 10 times 35 equals 350. And then we're going to subtract. 5 minus 0 is 5. We can't take 5 from 2, so we're going to cross out the 5, make it a 4, and then go 12 minus 5 is 7, and then 4 minus 1 is 4 minus 3 is 1. Now we're going to see how many times does 35 go into 175 without going over. 35 times 1 is 35. 35 times 2 is 70. 35 times 3 is 105. 35 times 4 is 140. 35 times 5 is 175. I can hear it. Stop, Mrs. McGuire, we're there. 35 times 5 equals 175. So my next partial quotient is 5 because 5 times 35 equals 175. 175 minus 175 is 0. Add together my two partial quotients. My final quotient is 15. So the question is, if the fence is 52.5 meters long, each length is 35 at 3 5/10 of a meter or 3.5 meters long, that we are going to have 15 sections of fence. Awesome. All right, let's look at number 10. Now, number 10, we're dividing a whole by a decimal. So this is not quite the same as what we've been doing all this time. I think they wanted to make sure we still knew how to do this from yesterday. So we are going to say, okay, we have 42 divided by 7/10. Well, that is the same as how many, 42 is equal to how many tenths? That's right. 42 is equal to, I don't know if you know this, but 420 tenths. Because 42 wholes, remember there are 10 tenths in one whole, so 42 times 10 would be 420. And then 7/10 is equal to 7/10. Then, now that we have our tenths, we're going to go, all right, we're going to say, remember, a tenth divided by a tenth, they do cross cancel. So then how many, what is 420 divided by 7? We can look at our multiples of 10 chart and fill it out. So let's see, how many multiples of 10 does 7 go into 420 without going over? 7 times 10 is 70. 7 times 20 is 140. 7 times 30 is 210. 7 times 40 is 280. 7 times 50 is 350. 7 times 60 is 420. 7 times, oh, that's right. We need to stop because we're only going into 420. So 7 times 60 equals 420. Our first partial quotient, and in this case only, there's not really a partial quotient because 420 minus 420 is 0. So 420 divided by 7 is, in fact, 60. So with that, you're going to go ahead and continue your work. I am just so proud of how hard that you're working and you're pushing through with this really new concept. This is definitely new to 5th grade. So you're going to go ahead and do pages 361 and 362 on your own. As always, you can email your teacher if you have any questions. Otherwise, I will see you next time.